Hello, my name is Yu Lei. I'm assistant professor at Department of Chemical and Materials Engineering at UAH. So my research area is energy, and so today I'm going to give you a very short presentation on finding alternatives to the energy challenges. So it has been estimated that the energy consumption of the world will double from 2000 to 2040. So where can we fill this hole? Right? So as a chemical engineers, we dedicated to solving these problems. So the energy and environmental concerns have spurred the advancement on solving these problems, developing new processes and materials to solve this energy crisis. So from chemical engineering point of view, here is how we are going to solve the problems. I'm going to show you a simplified roadmap of energy. I left out nuclear energy and coal and other resources, wind energy. Just want to focus on the chemical side. So first of all, we have crude oil, natural gas, biomass-derived feedstocks, and solar energy. So remember, we also have coal and nuclear. I didn't include here. And mostly we use for residential uses, industrial production, and transportations. So let's see one by one. From crude oil, most of them goes to transportations. So we use it every day for the liquid fuels. And some of them goes to industrial productions, and we use some of them for residential usage, and some of them will go for production of electricity, so to power plants. Natural gas is another source that we consider more cleaner than the crude oil because it's produced less CO2, CO, and other byproducts. And it's a good resources of hydrogen. So most of them goes to industrial usage and we use it at home for heating, and large amount of them goes to production of electricity. Right? Biomass, it's new resources that we can use, but only a smaller amount of biomass feedstock we can use for all these fuel purposes. And solar energy is cheap and it's clean. However, it's the most challenging one that we can use right now. So only a small amount we can use for production of electricity. Maybe you noticed that, and some of them we use for the heating at home. So many of those processes involve knowledges in chemistry and chemical engineering, and we will bring in, as chemical engineers, we will bring in our expertise to improve the efficiencies of many of those processes and hope to increase the efficiency of those processes and decrease the environmental effect of energy consumption. Right? And of course, the electricity will go for further usage at home, industrial, and transportations. And we are using more and more electricity for the transportation in the electric cars. Right? So to deal with the energy issues in our lab, we mostly go for researches in energy conversions and storage. So the purpose is to develop new materials, especially nanomaterials, and new processes for these materials to produce and storage of those energies. So for energy conversion, I mean current strategies convert crude oils to liquid fuels that we can use in our engines, and also improve those crude materials to value-added chemicals so we can produce polymers, plastics that we use every day, and using refinery and reforming techniques. The other thing is we try to identify new resources that we can develop renewable energies, for example, solars and biomass feedstocks. And follow the energy conversion, we need to store these energies. For example, sometimes when we produce those energy in another form, we don't necessarily use them immediately. For example, solar energy, we have sunshine during the day, but the peak of electricity usage is during the night. So we need some materials that can store those energies so we can use them at night. So we try to develop new materials that it must be safe. That's the most important thing. And another thing is cheap, so everybody can use it, and it has high performance and capacity, and which can beat the conventional materials products we have right now. Some of them examples is lithium batteries in different form and fuel cells. So here is the first thrust that we have in the lab. It's energy conversions. The first one is green chemical productions. For example, we try to develop new catalysts so we can develop new processes which allow us, in this example, is propylene epoxidation. to form propylene oxides. It's the top 50 chemical produced in the world. And we were able to replace the toxic organic molecules with clean air. By using this process, we were able to significantly reduce the amount of byproducts, and we replaced the toxic reactant with clean air, and we also reduced the reaction energy. So first of all, we reduce the energy that have to deal with the waste, and it also help us to improve this process become an environmental friendly process. And some other research we have is develop liquid fuels from biomass feedstocks. So it's also very challenging research because there's different technical issues, and we were trying to synthesize high performance catalysts that are resistant to leaching, deactivation, and carbon deposition. And another one is solar cells. So we are trying to develop new functional materials that can improve its high efficiency to convert solar energy to electricity. And once we have investigated those areas, we'll see how we can storage those energies. So one is the lithium-ion batteries that we use it every day now in our iPad, cell phones. So one major issue besides the safety is the fading issue of these batteries. So the capacity will decrease significantly after several usages, charge-recharge cycles. So we use a technique called atomic layer deposition to provide a thin film of alumina to coat the cathode materials of lithium-ion battery that significantly help with solving these problems, published last year. And also there's a new kind of lithium battery, there's the lithium oxygen battery. So instead of using complicated inorganic materials, we use oxygen as the cathode reactant. So because it's air, so it's abandoned in the earth, and it's cheap, and it also significantly decrease the weight of your battery. So it will be perfect for many usages, and it will significantly decrease the weight of our electronics as well. So last year we also able to develop new materials to realize these lithium air batteries. So as a demonstration here, we're trying to develop new generations of materials that are important in solving energy crisis of our time, and we're also looking for highly motivated graduate, undergrad, and high school students to participate in our researches. And you're welcome to check with our website and contact me for further information. And thank you for your attention.